You know, most of reality is completely invisible. It's true. The universe we actually see, all the stars, the galaxies, you, me, it's just the shimmering tip of this vast, wonderfully strange cosmic iceberg. So what exactly is hiding in the dark? Well, let's take a tour of the other 95% of reality, the part we can't see.
Our tour starts with a kind of cosmic tug of war. Okay, so on one side, you've got this immense, invisible pull. It's a force that acts like the universe's great sculptor, gathering up all the matter into the incredible structures we see scattered across the night sky. But what is it?
And then, on the other side of the rope, there's an equally mysterious push. It's this persistent, strange energy that's not just expanding the universe. Oh no, it's actually hitting the cosmic accelerator, driving everything apart at a speed that's always increasing.
And the answer to both of those cosmic questions is right here on this chart. And it's pretty shocking. It turns out that everything we can see, everything we've ever known, all the stars, planets, and gas, makes up this tiny little 5% sliver of the universe. The other 95%? Well, that's a cocktail of these two mysterious components. Dark matter, that's the invisible force pulling things together, and dark energy, the strange force pushing them apart.
Now, this really strange recipe for the cosmos has a scientific name. It's called the Lambda CDM model. Now, lambda is just the symbol for dark energy, and CDM stands for cold dark matter. This is our best working theory for how the universe is put together, so let's break down those two mysterious main ingredients.
All right, first up is the cosmic architect, the powerful, unseen force pulling everything together, dark matter.
So what even is this stuff? The thing is, we can't see it, we can't touch it, we can't detect it with any of our instruments, and that's because it doesn't interact with light at all. But we know it's there. We can see its gravitational effects everywhere we look, acting like an invisible glue that holds entire galaxies together.
So, the CDM in our standard model stands for cold dark matter. Now, cold here doesn't mean temperature, it just means it moves relatively slowly. It's not zipping around like hot particles that are too fast to ever settle down. And that slowness? That is the absolute key. It allows dark matter to clump together under its own gravity, forming these massive, invisible foundations that galaxies can then build upon.
And this image right here brilliantly illustrates the result. What you're looking at is a simulation of the cosmic web. The bright nodes, yeah, those are galaxies. But the underlying structure, those vast interconnected filaments, that's a cosmic scaffold made entirely of dark matter. It is the invisible skeleton upon which the entire visible universe is built. It's just incredible.
But how can we be so sure it's really there? Well, one of the clearest pieces of evidence comes from just watching galaxies spin. The stars way out on the edges are moving so fast that the gravity from the matter we can see just isn't nearly enough to keep them in orbit. They should literally be flung out into deep space. The only explanation that works is that these galaxies are sitting inside a massive, invisible halo of dark matter, and its gravity is what keeps the whole thing from flying apart.
Okay, now for the other side of this cosmic contest. If dark matter is pulling everything together, what in the world is this mysterious force that's pushing it all apart? Let's meet dark energy.
Unlike dark matter, which clumps together to build stuff, dark energy seems to be a property of space itself. Think of it like a kind of anti-gravity, a repulsive force that's woven right into the fabric of the cosmos, causing space-time itself to stretch and expand faster and faster over time.
This timeline shows you exactly how that cosmic battle played out. You see, for the first several billion years, gravity was the clear winner. It was pulling matter together, slowing the universe's expansion. But as the universe got bigger and bigger, gravity's influence got diluted over these vast distances. And then, around 10 billion years ago, dark energy's constant, steady push finally took over, and it's been accelerating the expansion ever since.
So how did we discover this shocking acceleration? Well, we used something called cosmic yardsticks. See, certain exploding stars, called Type 1a supernovae, are incredibly useful because they always, and I mean always, detonate with the same intrinsic brightness. So if we measure how dim they appear to us, we can calculate precisely how far away they are and literally map the expansion history of the universe. It's pretty clever.
And the results of all those measurements is, well, it's staggering. Dark energy makes up over 68% of everything in the universe. It is by far the dominant component of our cosmos, and here's the kicker, we have almost no solid idea what it actually is.
Okay, so dark matter and dark energy dominate the huge large-scale structure of the cosmos. But this unseen reality also contains these points of extreme mystery, places where our understanding of physics completely collapses. So let's talk about black holes.
Deep down, at the heart of every single black hole, our theories tell us there lies the singularity. It's a point where matter has been crushed to infinite density, and space-time has been infinitely curved. It's right here that our two great pillars of physics, general relativity for gravity and quantum mechanics for the really small stuff, they just stop making sense.
The physicist John Wheeler described it perfectly. He said a singularity is where these two master theories must finally meet in a fiery marriage to create a new unified theory of quantum gravity. It's not just a place in space. It represents a true frontier of human knowledge.
And here's where it gets absolutely bizarre. Black holes seem to obey their own version of the laws of thermodynamics, the laws of heat and energy. For example, the surface gravity of a black hole behaves just like temperature, and the area of its event horizon acts just like entropy, which is basically a measure of disorder or information. The fact that these laws line up so perfectly suggests there's some deep hidden connection between gravity, information, and the very nature of reality itself. It's wild.
So, ultimately, black holes are so much more than just cosmic vacuum cleaners. They represent a fundamental challenge. They're a message from the cosmos, basically reminding us just how much we still have left to learn.
Okay, for our final stop on this tour, we're going to go from the infinitely dense to the seemingly empty. We're diving down to the smallest possible scales to explore the secret energy that's hiding in empty space itself.
It turns out there is no such thing as truly empty space. At the quantum level, the vacuum is a seething, simmering foam of energy. Thanks to the weird laws of quantum mechanics, pairs of virtual particles can just spontaneously pop into existence from nothing, interact for a split second, and then annihilate each other. It really is emptiness with an attitude.
And these virtual particles, they're not just some mathematical fantasy. They actually mediate the fundamental forces of nature. The electromagnetic force that you experience every day is really just the exchange of virtual photons. And their collective energy is very real. It can create a measurable force, called the Casimir effect, that can literally push physical objects together in a vacuum.
And here's where we bring it all back home. It's thought that tiny quantum fluctuations, tiny jitters in the vacuum of the very early universe, were stretched to enormous cosmic sizes by inflation right after the Big Bang. Those tiny fluctuations became the seeds, the gravitational starting points, for all the galaxies and cosmic structures we see today. The biggest things in the universe were born from the absolute smallest.
And that really brings us to the final, profound takeaway from all of this. From dark matter's invisible scaffolding to dark energy's mysterious push, from the law-breaking hearts of black holes to the simmering energy of nothingness, the vast majority of reality lies completely beyond our senses. Which leaves us with the ultimate question. If 95% of reality is hidden, what else are we missing?